webinar series. My name is Isaiah Donaldson, and I'm the marketing specialist here at DISYS. Today's webinar is Energy's Great Breakthrough, Analytics, Optimization, and the Digital Oil Field. Today's webinar, if you would like to find out more information on DISYS and the services we provide, please visit our website at disys.com or one of our many social media pages. We have muted everyone, so those who have questions for our presenter, we encourage you to ask your questions via Twitter with the hashtag #OilfieldWebinar. For those who do not have a Twitter, you can post your questions in the chat box located in the GoToWebinar panel towards the bottom. Also, we will also be conducting a poll in the middle of the presentation, so look for that also in the GoToWebinar panel. Our speaker today is James F. Gaulke, CIO of PDC Energy. James has been with PDC since 2009. He is responsible for redesigning how field information is brought back into HQ for immediate processing and bringing digital intelligence to a field historically relying on spreadsheet analysis. Prior to joining PDC, he served 10 years as VP Systems Chief Information Officer for Nordstrom Bank and served 12 years with General Electric Capital Corporation in various roles of increasing responsibility. James holds an MBA in Finance from Kennesaw University and a BS in Mathematics from Iona College. James, I'll pass it over to you now.
Thank you, and good morning, everyone. So I wanted to start off with talking about, let's make sure the screen comes up first. Big data. And Amar, are you able to see the screen on the presentation? For some reason, I lost my connection.
It's up on the screen.
Okay, thank you very much. So first thing I wanted to talk about is big data. Business leaders, us and the folks that we all report to, are eager to harness the power of big data. So the first thing I wanted to do is just make sure we level set on what big data is and how it's used from an oil and gas standpoint. Secondly, wanted to cover into street credit and kind of go through the data journey at Nordstrom and what we were able to accomplish, and then do the same for what our journey is here at PDC and how we're entering into and leveraging big data. And then kind of go through the lessons learned from both of those exercises and compare and contrast Nordstrom against PDC Energy and talk about the 5 key themes. So for big data, first, there's not one definition. It's actually a term that describes at least 3 separate but interrelated trends. First, there's capturing and managing lots of information. Data volumes are doubling every year. Couple that with the fact that the businesses are asking us to store at least 3 years of data, and in most cases more, just further complicates the issue. Second, we work with many new types of data. 80% of the data that's actually stored is unstructured, things like images, audio, tweets, text messages, etc. And until recently, a lot of organizations were not able to take advantage of those themes or that data. And third, exploiting these masses of information and new data types with new styles of applications. There are many tools and technologies designed to work with large volumes of information, and that information and the volumes have been constantly changing for the past 15 years. Therefore, new tools and technologies need to be developed, and all are based on the next generation of big data. And these 3 trends are what brings about the potential to transform your business. As I mentioned, just as there is no single definition for big data, there is no specific cause for what's behind its rapid rate of adoption. Again, several distinct trends have contributed to big data's momentum. And the first is we have new data sources. Traditional enterprise applications are your first source of data. That 3 years that I was talking about in terms of saving before, coupled with the increasing volumes, tend to be what most organizations go to first. We save that transactional data for a number of years to analyze trends. And in the Nordstrom case, we actually used it for 7 years versus 3. And today, there are more generators of information than ever before. Mobile phones, tablets, sensors, such as the SCADA and the PDC environment in the oil and gas field, medical equipment, wearables, and other digital platforms that gather and report vast quantities of information. Second, there are larger information quantities. Consider this. And over a history in IT that spans 30 years, SQL databases began and traditionally just held gigabytes. In 2000, when we started developing the Nordstrom warehouses, we began expanding the volumes of data, and the expanding volumes went into terabytes. At the time we did the development, Microsoft actually needed 4 clustered SQL servers to handle that much data. In the last 5 years, big data has pushed the limits of file stores to petabytes of information. And just as an example, when we were talking terabytes before, you can pretty much buy a USB drive that has a terabyte of information contained within. Third category is we have new data categories. And that really helps explain how you go from giga to tera to petabytes of information in your environment. In the past, as mentioned, most databases held records of complete, finalized relational data known as transactions. In big data, subtransactional data plays a big part too. There are things like click trails through a website, how you manipulate your shopping cart, tweets, texts, and don't forget the world of unstructured data, photos, videos, audio, and XML documents. Lastly, there's commoditized hardware and software. There are reduced costs of storage that allow you to save all this data about how the asset is performing, and this low-cost hardware and software environments have transformed technology and our ability to process the data. I'd like to try the poll right now if it works. It doesn't look like it's going to, but I'd ask the question of where are you on your data journey? Are you starting out? Are you doing internal data only? Are you experimenting? Or do you have a full-board data scientist team using large-scale data sets, etc.? And there really is no real answer for this. In some cases, organizations are just starting out, building data warehouses, and actually seeing great success. There is one oil and gas company I know of that started with financial data warehouses and is doing things with capital management and answering questions that were not able before, to a large oil and gas company that has a full-board data scientist team using large-scale data sets, etc., where the CEO claims they're kind of on second base, have not hit a home run yet, and trying to figure out what they're doing with the data. So let me talk a little bit of history and the street credit. And I'll start with talking about the journey at Nordstrom Bank. For those who don't know Nordstrom, it is a department store. And the bank I worked in was a wholly owned subsidiary of that department store. We processed credit cards and bank accounts and grew the portfolio from $700 million in 1999 to over $2 billion in 2008 with 4 million credit card customers. It made Nordstrom Bank the 25th largest issuer of Visa credit cards within the country. Initially, the bank started as a money-saving move, taking our customer and transactional data at DISYS and bringing it in-house to do reporting as opposed to paying for the same functionality with that third-party processor. Once we had our data in-house and completed the process of creating our credit data warehouse, we realized we had the power to combine 13 disparate customer databases to come up with one single source of truth for a customer. For example, we had multiple catalog mailings. There were 3 or 4 catalogs being mailed to the same address. If you were in New York and maybe wintered down in Florida, I was sending you one catalog to New York. Maybe I sent it to your office if you had something shipped there. And then while you were in Florida, I sent it to your Florida address. And as a result, I had these 3 to 4 catalogs going to various customer addresses all over the place. The way we accomplished the fix was identifying our customer base and pinning our customers using an outside source, realizing that this became an internal key. And this particular key allowed us to match name and addresses in a most probable format, saving about $3 million to $4 million in catalog mailings year over year. But then we realized we could capture that customer via self-identification on transactions. So matching up the shipping addresses, alterations, and other items where customers voluntarily handed over those addresses. We begin to tie that information together and get an idea of customers over time. Utilizing own payment vehicles to identify the customer and combine the data, we were able to look at what customer spend patterns was and actually look at what they were most probably likely to buy compared to what they thought they would buy. And this allowed for analysis, personalized marketing messages on various forms of communication. For example, if you were a Nordstrom cardholder at the time, you might remember the letters individually crafted from the store that came with your monthly bills. We were able to look at your past spending patterns and provide customized messages to each of the marketing persons or each of the cardholders about what was happening in the store, what sales were going on, what specialized trunk show, and provide for customer service, or the capability to service the customer across these multiple storefronts and across these multiple channels. We were also able to take in and start servicing web as well as catalog in addition to the credit phone bank and service that customer with one phone call. Then, realizing we had the credit, we had the customer, we had the transactions, we began purchasing demographics to better understand our customer. And what we were doing in demographics was matching likes. So we were taking married customers and matching them with non-card holders who were married, or people with families, or people with pets, multiple demographics, and it allowed us to understand what Nordstrom card holders did versus non-card holders. In purchasing these like demographics, we had better identification of individualized customers when certain things were held constant, such as geographic area, earning potential, family size, marital status, etc. And these demographics, coupled with the like customers, eventually led to the Nordstrom loyalty program, or what is now known as Nordstrom Notes. At the time we implemented it in 2007, it was a point per spend program where 2,000 points equals a $20 Nordstrom note. And it developed loyalty in the fact that these notes were large scale, wouldn't fold comfortably into your wallet, so you were constantly reminded you had it and wanted to spend it. And eventually, that led to a program that provided 37% incremental sales lift to Nordstrom, which was helpful in 2008 and 2009 as the retail economy tanked. So we were able to take through this data journey, not really knowing what we wanted to solve when we started and went down, the capabilities to look at our internal cardholder customers, look at spend patterns, look at transactions, compare them to non-card holders, and come up with a loyalty program that contributed to the business. Now we get to the highly correlated field of high fashion retail and oil and gas. So for PDC, it is a Denver-based company. It's 40-year-old independent upstream headquartered in Denver, Colorado, which means we focus on production, development, exploration, and marketing. In fiscal year 15, we had $620 million in revenue. We owned an interest or operated over 2,900 wells, primarily in the Colorado, in the Wattenberg field in northeast Colorado, and we're developing a Utica shale play in southeast Colorado. Net production in 14 was 9.3 million barrels. In 15 was 15.4 million barrels. And in 16, our guidance, which has recently been increased, is above 20 million barrels. We have about 2,150 proven horizontal locations with about 273 million BOE of reserves as of fiscal year 15. And given recent acquisitions, these numbers have changed. At PDC, we faced a different scenario. Data took up to 60 days to get into systems from the field when I got here. The longer data it takes to reach my business partners, the more out of date it becomes, which means decisions on how to operate the company and how to effectively leverage is being made with subpar data. Data was also locked in departmental and application silos. Data integration was a foreign term. Much was done on spreadsheet with downloads, manipulations, uploading to the next system. Information existed across multiple systems and was difficult to access. And, as you can guess, data was duplicated across the enterprise. There was no central repository for our data, no single source of truth. For example, the simple question of how many wells do we operate produced at least 4 different answers with a plus or minus 10% variance, depending on who you asked and what system you went to. Well counts were stored in various systems and could be interpreted differently based on horizontal versus vertical integration, could even differ based on operated versus non-operated wells. Do you count wells being drilled but not completed when you're asking the well count? Do you count wells shut in for maintenance that are not producing? Do you count wells that have been spudded or being digged? Or do you even count wells in planning? Each system and each department defined a well separately. And as often quoted, there's a statistic that says that 90% of the world's data was created in the last 2 years. With the pace of shale and horizontal drilling more than doubling in the past 2 years as well, it may be safe to say that the rate of data proliferation in the upstream industry, and even within PDC, is even higher than in other industries. It was important to get a handle on how the company was performing, especially as the industry grew and the expectations on our production capabilities increased. And studies indicate we need to produce 30% more product than we do today within 15 years to meet global energy needs. First, we had to go back to basics and get our ERP functioning appropriately, and that's what you see on the bottom of the pyramid with the word financial. We run Bolo from P2 Energy and needed to clean data and ensure it was processed accurately and timely. And then we had to integrate our data to enable getting the right information into the right hands at the right term. So we focused on costs and cost visibility first. The company seemed to be doing okay with revenue streams, but we had to understand where the cash was going and classify it appropriately. The accountants had a good handle, or so they thought, on our cost structure, but our production guys weren't getting the information they wanted, such as horizontal slicing and dicing of data versus the vertical slicing and dicing based upon the organization. We had to understand our financials, make sure we got everybody to agree on details, and then spread that out into data cubing and data marts. And that gave us things like estimated cost of capital projections against field estimates and actual expenditures occurred, and gave us visibility into where the money was going, how much was spent, how much we had budgeted for completion of a well, and how much was left to actually complete it, whether we're going to be coming in under or over budget. Due to our ERP use, our land department also came along for the ride. But we needed to help them manage complex leases and provisions, as these important guidelines in many cases were just noted in free-form text. So we had to help our land team, help our production team, avoid violating lease terms that PDC may have never completely understood. Completing both the financial and the land side, an understanding of the company structure, helps us get to a fully profitable model. And what we were talking about was a lease operating statement, but not the way the accountants saw it, but something that included things like windshield time of pumpers that were driving between wells, allocating that back to a well, fixed overhead costs, etc. And what we were able to do in this particular case was the ability to view and analyze financials across cross centers, accounting codes, ad hoc capabilities, and actually give data to our operations team to make them effective in how they fixed and how they handled our well information. And this was provided at the well level, at the pumper level for those that managed it, at the field level for that the pumpers reported into, at the basin level for everything that we were drilling in a particular area, and eventually at a company level, all in a drillable format up and down the pyramid, so that folks were able to get to the same information at the same time and have good quality conversations about what the data meant as opposed to the data itself. After solving that problem, and due to Colorado legislation, we quickly got into equipment. What assets were on a well site, how long they were running, what was producing greenhouse gases. The end result was we had a compliance report out of the greenhouse gas emissions process that used to take 6 months and was now completed in relatively short time of a few weeks. And we became an integration point for passing equipment data back and forth between our environmental health and safety people, as well as our construction people when they were putting walls together. And then we were able to take and update field capture application system to include these non-production greenhouse readings. Combining that information, we then realized we could move into the definition of a well and integration of data across systems to create a well master. This visibility into ops, non-ops, current well status, etc., gave us a single definition of the truth about a well and is expected to help PDC drive effective enterprise-wide operations as we continue to use that particular product. Today, we're working on production information, what the well produces with the expectation of visualizing on dashboards or a central GIS mapping solution or even potentially Spotfire in terms of what we do and where we go. We're also leveraging an outside company to bring in well fracturing data so we can understand how many segments were actually fractured, how those segments are produced. And where we get into the big data pilot is I look at SCADA, which is the information or the equipment that is on my individual wells, as producing every 3 seconds in terms of pressures, volumes, temperatures, and other items about how that well is performing. We're taking that and we're moving into our big data pilot, which I'll talk about at the end of the presentation. And the data journey continues here. Between those two lessons, doing the compare and the contrast, really what I wanted to talk about was 5 areas where I see things in common between that credit card environment and the oil and gas environment. Namely context, starting somewhere and capitalizing on it, keeping the work you do simple, finding those folks in the company that understand and appreciate what you're doing in terms of the statistical analysis, and then good tools that enable good processes. So first, diving in, content and process are essential in terms of what you're doing on your big data journey. The sheer volume and complexity of big data means the traditional method of discovering, governing, and correcting information may not apply. Before starting down any journey, you need to school up on the latest best practices and industry standards as it relates to big data. For example, in the oil and gas world, if I had to do it over again, I would look for industry standards, best practices, and data standards such as PPDM for the petroleum business that I did not know about coming in because I came with a credit card/retail environment. Also, have an idea before you start down the big data path. Why are you swinging that particular tool? What insights are you looking for? And what are the kinds of things you want to solve with big data? Having an idea of what your pressing problems are help identify what data you want to seek out and begin saving, how you need to clean it, who needs to own it. The organization needs to understand what it needs to care about, what's going to drive value, and why it's going to drive value. Then, and only then, can you have that conversation about where does the organization find the key data. What applications, what manual repositories, what outside sources. It's a fundamental need to understand the data before you start saving and manipulating it. Information integration and governance must be implemented within big data applications, providing appropriate governance and rapid integration from the start. A solid information integration and governance program should include automated discovery, profiling, and understanding of diverse data sets to provide context and also to provide and enable employees to make informed decisions. Lastly, you need to figure out how you are going to boil this particular data ocean. What problems get solved first? Then how do you expand on that data to solve new and more complex solutions? Or how are you going to bring in complementary data to solve issues and problems? But that's not all. You also have to pay attention to the technical side. At the end of 2013, the amount of data stored exceeded over 4 billion terabytes, or 4 zettabytes. That's approximately 50% more data than the digital universe held at the end of 2012, and 4 times as much as 2010. And if you follow that algorithm, basically data is doubling every 2 years. Companies recognize their big data contains valuable information, and they are eager to analyze it to obtain actionable insights and gain competitive advantage. However, any big data effort is going to amplify existing problems in your infrastructure. It's the process of data manipulation itself. Therefore, you have to deal with the 4 V's as you build out the platform. And those 4 V's are variety, volume, velocity, and veracity. The first, plan for variety. Multiple data sources such as customers, salespeople, vendors, spreadsheets, reports, machine data, etc., and multiple data types such as structured formats and databases, ERP platforms, documents, email, video, audio, etc., all have to be handled. It is inevitable, so try to understand what is coming in and why you're bringing it in. Then, plan for volume. As your data grows, be sure you have the storage and horsepower for minimizing batch times and avoiding bottlenecks. You need to save and process what you are saving. Then, plan for change and rapid movement, or what I call velocity. If you are using your data solution for integration, then plan for high performance to get the data in, manipulated, and extracted for the destination system. That's critical if real-time or near real-time performance is needed. Lastly, you have to trust your data, and that's veracity. Data that is accurate, current, and complete builds trust in the solution and its answers. You can only take advantage of the opportunities available in big data when you have processes and solutions that can handle all 4 of the V's. Third, start somewhere and capitalize on it. As with Nordstrom and with PDC, solve pressing issues and build the infrastructure to move forward. Start small and leverage your successes into another logical area of the business. I think the logical thing in terms of trying to analyze big data is not just to put a bunch of data scientists into a room, let them play with the data and see what comes out. You really need to look at what business problems are you solving, how are you going to deliver data swiftly in order to provide value and drive additional opportunities. You need to be agile to accommodate a wide variety of data and seamlessly integrate with various technologies. And also, you need to try and grab data as close to its creation point as possible, the place where it is most pure. Only then can you automatically discover, protect, and monitor that sensitive information as part of your big data applications. There's a lot of conversation about data warehousing initiatives versus big data initiatives. And obviously, data warehousing doesn't get the huge push and the huge hype that big data or analytics gets. But data warehousing and small efforts in trying to solve business problems are a proven practical solution for giving users access to the data they must have and they need in order to do their day-to-day work. And these data warehouses and the efforts you make on the data warehouses can drive towards those big data solutions and those big data pieces. It's another way of keeping it simple, knowing what your peers want and need. And capturing benefits from big data requires knowing what your peers want, being able to find the key items within these larger masses of data, and being able to deliver insights and solutions to those particular problems. The only way to do that is to begin by articulating the goals of the business. Determine the analytics and the reports necessary to support those objectives. Now you can make decisions about the data needed to inform and provide those reports or those insights, those dashboards or those analytics. Standard terminology is going to be a critical piece of this process. There should be no understanding about the items that you're trying to solve or the data that you're manipulating, things such as what is a customer, what is a sale, or what is a well. With standard terms, organizations can create standard policies such as defining the data that compromises a complete record. And as an example, within the Nordstrom Bank environment, when we talked about a sale, there were multiple points at which a sale could be considered complete. Was it complete when the customer made payment at the register and walked away product? If that's the case, how do you handle refunds or returns? So was a sale complete when the customer hadn't done any type of returns within an X number of period? Or how do you handle missing items within that sale process? I talked about the well information before in terms of at what point is a well considered a well. When you start digging it, when it's completed but not producing, or when it's producing, or even when it's been turned on from a sales standpoint to refineries. With standard terms, as I mentioned, organizations can create those standard policies, and that data definition is what you derive to get to your complete record. And you have to make sure your infrastructure is solid. Armed with objectives and standard terms and policies, teams can create data processing flows that automate the extraction of relevant information from the masses of the systems that are producing big data. Understanding where the data is coming from, how it is being manipulated, and where it is going builds trust in the solution and trust in the answers that the solution produces. You don't want to destroy that by having people watch a swirling hourglass or something else on the system. A good example of that was when we first tried to pilot what we were doing here from a PDC perspective. We used an outside vendor appliance that would hopefully get us better answers and faster answers related to our data. That particular appliance could not keep up with the volume of information coming from a well, and as a result, hourglasses would spin and frequently queries would time out. We had to go in and fix that. So it's good to pay attention and not trust everything that a vendor is telling you. Lastly, on the fourth item, you need to find your company's quants. You want to find those business peers to play an active role in information-centric projects and to collaborate with the technical teams. You need to grab the folks who perform that task today, those folks that are manipulating spreadsheets, providing charts, and providing executive reports. You want to make them part of your big data team. Even if only you start by automating what they do today, what you actually do is allow them time for deeper analysis. It's been estimated that knowledge workers spend approximately 79% of their time identifying and preparing the data they need. By contrast, an integrated system that puts data in the hands of the correct people reduces the time needed to identify and prepare data down to about 15%, saving those knowledge workers over half the time they used to spend just prepping the data for analysis. Think about what your folks can do with that extra time and those insights that your data can provide for them. An organization with a consistent understanding of information, what it means, how it is used, and why it can be trusted is the end result of this whole game. Decisions are more accurate, and business opportunities can be readily captured. Lastly, you want to choose familiar tools. You are asking a lot of folks to understand data sources and flows, so you want to make it easier on them to understand the end result and gain insight. And those good tools enable good processes. There are a ton of tools out there that you can evaluate for your big data needs. As you do, there's just a couple points to really consider. One, you want to remain agile to accommodate a wider range of data or a wide variety of data. Two, you want seamless integrations with various technologies, both those you have in-house and those you might want to migrate to based on your roadmap. Third, data integration. There are multiple integration capabilities for batch data transformation and movement, real-time replication, and data federation. You want to automatically discover, protect, and monitor sensitive information, security permissions, and privacy. Lastly, master data management, or the management of business terms, definitions, and categories is critical. You'll need a full data lifecycle from creation to retirement and archiving of data. And lastly, you want your metadata to be collaborative. All teams should have an ability to stay connected and be consistent. So as with anything, big data comes with its own unique set of obstacles that you must find a way to overcome. Information growth, over 80% of the data in an enterprise consists of unstructured data, which tends to be growing at a faster pace than traditional relational information. Processing power, the customary approach of a single, expensive, powerful computer to crunch data, no longer works. You must divide and conquer using commoditized hardware and software. Physical storage, although cheap, the capturing and managing of all this information can consume enormous resources, outstripping your budget expectations if you're not careful. You'll have data issues, the lack of data mobility, proprietary formats, interoperability obstacles can all make working with big data complicated. And hopefully, as you solve those 4 issues, information growth, processing power, physical storage, and data issues within your company, you can use some of the tips, successes we've used to make your big data projects a success. So I wanted to kind of circle back onto a previous slide and talk about where PDC currently is in terms of what it's doing with its big data. As mentioned, we have SCADA on a majority of our large wells. That SCADA and that information, or that SCADA device, measures information on the well, such as pressures, volume, production capabilities, temperatures, and assorted other items. And we wanted to build one predictive model using that SCADA information and high-resolution data to predict the yield from a well. So really what we're doing is taking a mom, god, and apple pie concept that the higher a pressure is within a well, the more oil and gas I will produce, but actually prove it using big data tools and techniques. And the thought process being, if we can do this, then what we're basically doing is taking the thought processes around those tools and techniques, we're learning them without really kind of questioning the information that is showing us because we know it's theoretically true. So the yield, or what's being produced from a well, would be considered as gas production, oil production, and water production individually or as a combination of all the values of a barrel of oil equivalent. We're trying to identify correlations between the variables that are present in the data, and then visualizing the model results and the correlation using coefficients or Power BI, and then complete the data loading of SCADA data and high-resolution data from the database to a staging area using powerful databases. And in particular, what's important to note on this one is historically PDC would only gather that data on a daily basis, once a day, in terms of how the well was performing so that pumpers could fill up production reports. We've gone through extensive IT modifications to allow us to pull that data across the field in 3-second intervals, store it within what we call a historian, and basically begin the process of the data warehousing analytics from a SCADA standpoint. We think that going through and actually doing this will have capabilities for operational efficiency, production optimization, collaboration, decision support, data integration, and workflow automation. But in order to accomplish that, as with anything else, we have data cleaning that's necessary. So in our environment, even though it's a known quantity of wells with SCADA, it's all our equipment and very similar SCADA devices on all the wells, we still have data cleaning we need to do. Things like duplicate values or well data. These duplicates are based on Merrick, and this Merrick is a piece of software that we run to actually do field integration and record dates. We have to figure out why we're getting the same records coming over in our processes and basically remove those that are duplicates. We also need to remove null values. Some of the SCADA was providing zeros or null values in casing pressure, tubing pressure, line pressure, and the differential pressure within the well. We also, in some cases, had negative values coming in. These negative values in casing pressure, tubing pressure, line pressure, etc. And these differential pressure values greater than 0.05 negative were considered as 0. And in this case, what we're really trying to do is not necessarily eliminate data or eradicate data, but removing what we know is erroneously wrong data. There is not a reason we should be getting negative values coming in. There's something that's happening with these SCADA devices, so just treat it as a non-number coming in. And lastly, take a look and get ready to move to the outliers. Right? So anything in terms of gas rates that were beyond values we know a well could produce, or pressure differentiations that were beyond what is possible, were considered as outliers and were taken away. And with that data cleaning, we were then able to map, and in this case, it's casing pressure versus oil production. And what you're seeing is 4 different values or 4 different mappings put together, pretty much from a clustering effect, using the color differentiation, and you can start seeing some left to right incremental values. And again, this isn't a great insight. This is mom got apple pie, because as casing pressure increases, oil production should increase as well. But it's a way of taking a theory and using the big data tools and techniques, actually validating that these tools and techniques start producing reports. So as we go in and analyze things that we don't know or want to know about, we're not going to question the tool. We're not going to question the technique. We're not going to question the data. We're going to start questioning the results and looking at what those results mean and what they look like and what they actually can identify for us when we discover these correlations in the analytics between data that historically we haven't looked at before. Tubing pressure versus oil production did the same. We've got, and again in this case, 4 distinct lines, the purple almost going straight up, the green going at a 45-degree angle, the orange, if you will, at a 30-degree angle, and even a purplish that's going at that almost 1 or 2% angle over on the right-hand side. All that has meaning from tubing pressures. All those are different capabilities of wells, but all those are pretty much showing us the analytics around what happens from pressure variation in terms of oil production. And then we do the same for the line pressure versus oil production. In this case, the results are a little different. The visualization's a little off, and this is telling us that we kind of need to dig in a little bit about what's happening. Line pressure for us means I can't push the gas out to the refinery because the pressure within that line is particularly too high. And in that case, if I can't produce gas, I also can't produce oil. So this should be a little more correlated in terms of what we think is happening, but it's not, and we need to dig in and understand what's happening, what this means, what it looks like for us. And lastly, if I take everything combined from a model and put oil production in terms of what actually has been recorded by the pumpers against what our model predicts using the previous 3 skeins, we get a pretty good correlation. Actually get a 77.23% accuracy in terms of what's going through. And the reason this type of stuff becomes important for a PDC perspective is the digital oil field concept. And the whole digital oil field is being able to measure, monitor, and record things about the oil field, what's producing, workers, environment, and everything else that I have not been able to utilize in the past. And it's going to play a key role in the coming decades in enhancing the efficiency, the operations, and cutting expenses for oil and gas production. As a whole, the oil and gas industry needs to optimize operations, increase efficiency, and reduce operational costs. And the only way to do that is to gain insights into what's happening with your field from the data that's being provided. And this is what we look at in terms of capabilities and saying, if I build my big data now, because big data for oil and gas is going to be very separate from big data for a consumer company. Big data for oil and gas is all about the wells, is all about the production, is all about the efficiency of the guys in the field, whereas big data for retails is where you get into what is the consumer saying, what is the consumer buying, how does that marry to looks, and you get into unstructured data. I think big data for oil and gas as exists right now is all transactional and structured data, but the volumes of it from the number of wells, the number of monitors and monitoring points, capabilities to pull that up, both what's on the surface and downhole, and how are you going to store and correlate all that information. So in summary, and kind of taking the entire presentation together, context, contents, and process are essential. You need to kind of understand what business problems are we struggling with and how are we going to try and solve that, and then start down that path. Just keep it simple in terms of what you're doing, but start solving business problems with your data And don't try and take that whole ocean and boil it all at once. Take simple steps. Find those folks in your organization that have a desired insight into what's happening from an analytical standpoint, and then use good tools. There is no right answer. There is no hype answer. It basically is what tool makes sense to your organization and what can people process. And with that, I'll open it up to the audience for any questions.
I don't think we have any questions right now, James.
Okay, fair enough. So I think the next slide actually, Ben, Ahmed, is yours in terms of closing. And I just want to thank everybody for your time and attention today.
Yes, thank you, James. And thank you, everyone, for attending our webinar. If you want to find out more information about DISYS, visit us at DISYS.com. And as you can see, you can contact James with his information right on the screen. And we look forward to seeing you next month for our monthly webinar series. Thank you. Have a good day.